Good morning, good afternoon, good evening. Welcome to Questpond's YouTube channel, and today we will talk about a very important topic and a hot topic, machine learning. Machine learning with ML.NET C#. When you talk about machine learning and data science, artificial intelligence, Python is a forerunner. It has awesome frameworks like NumPy, Pandas, SciPy, which makes artificial intelligence and data science much easy to learn, much easy to use. So in case you are interested in those topics, you can go ahead and chat on questpond.com. You can see the website here, questpond.com. You can go and chat there. I will see that you get the video lectures of Python with machine learning. But for this video, my focus is on machine learning using C# and .NET technologies. Now, ML.NET is a great open source framework which is built by Microsoft specifically to do machine learning with C# and .NET. So this is the first lab, which is approximately of 45 minutes, and we are covering like 14 chapters in this first lab. So this is going to be a step-by-step series, for people who are very new to artificial intelligence and machine learning. So in case you have zero knowledge about machine learning, don't worry about it. So in this first lab, we have 14 chapters. So we will start first with basic definitions of what is artificial intelligence, what is machine learning, what are labels, what are features, what is a model, and so on. And finally, we will create a feedback predictive system wherein you put a feedback and will tell you that this feedback is good or bad. So let us first get started with the definition of artificial intelligence and machine learning. Once we know the basic definitions, then we can start the hands-on. One of the goals and fantasy of humans have been to create intelligent computer machines. Intelligent computer machines which can think like human, they can work, they can react like humans. This area of study is termed as artificial intelligence. Now, one of the capabilities of humans is learning, and depending on the learning, understanding things and making more better and accurate decisions. Machine learning is a kind of extension to artificial intelligence, where the system or the algorithm will automatically mature and improve from the training data we'll provide. So in other words, we will have an algorithm and we will provide him training data, and every time we provide training data, the algorithm will mature by itself. So we do not have to really make code changes, but the code gets matured, makes more intelligent decisions by learning from the training data. So let's try to understand what are the different things involved in machine learning to ensure that machine learning works properly. What are the different phases and steps involved in machine learning? The first thing, what you need is an algorithm. So depending on your situation, depending on your needs, your inputs and outputs, you need to make a choice of an algorithm. And to this algorithm, you would be providing training data. So the first step in machine learning is you need to have a training data and you need to have an algorithm which will get trained by this training data. Now, while you're training your algorithm with the training data, you need to be very clear with your expectations. In other words, what are the inputs to the algorithm and what is the expected output or the predicted output from the algorithm? So when you are actually training your algorithm, you need to say that which of the fields are inputs, that means features, and which of the fields are labels. Labels means the output which we want from the algorithm. For example, you can see that I have a simple training data of a feedback here. So what I'm expecting is that I will give the feedback to the algorithm and the algorithm should give me back the ratings, or it should actually predict the ratings, right? So the feedback will become the feature and the ratings will become the label. So features are inputs to the algorithm and labels are output which will be predicted from the algorithm. Once your training data trains the algorithm with proper features and labels, we get a very, very important output called as the model. This model is the heart of machine learning. Model you can think about as experienced algorithm which has gained experience because of this training data. And this model is what we will finally query and we expect the predicted output. So finally in production or in live environment, you only question the model. Now, it is very much possible that sometimes the model is not up to the mark. So what we can do is we can test this model's accuracy by providing him test data. And if it is not up to the mark, we can again go and refine our training data and retrain our algorithm again. So this is like a continuous process of training, testing, and checking if the model is up to mark or not. So again, I repeat, model is nothing but it is algorithm which has experience. It is the final important artifact of your machine learning process. So let's start with the first example, the first lab, that is lab 1 of machine learning using ML.NET C#, a predictive feedback system. In this predictive feedback system, we would build up a predictive feedback model which will take up a feedback text, and on the basis of this text, it will decide that this is a good feedback or this is a bad feedback. So for example, if somebody goes and puts a feedback saying this is nice, it will categorize this feedback as a good feedback. But if somebody says that that's bad, it will categorize this as a bad feedback, right? So we would like to go and build up a very simple feedback system, a feedback model, which will analyze the feedback text, and it will say that is this sentiment good or is this sentiment not good. So the first thing what you need for doing ML.NET is you need Visual Studio 2017 or above versions. So you can see here at this moment I have 2017, which is a community edition. A community edition is a free edition. You can go ahead. It has almost all the features of Visual Studio which is needed by a C# developer, right? So at least 2017 is needed. So anything below that will probably not make your examples working. So that is the first thing. And the second thing is all these examples we will be using .NET Core for demonstration. So we have .NET Core and we have .NET Framework. And if you see the future roadmap of Microsoft, everything is now .NET Core, right? So what I've done is I have taken up this 2017 Community Edition and I have created a simple .NET Core project. So you can see here I did a file new project and I have created a simple console app .NET Core project, right? In case you are new to .NET Core, I would suggest to go and watch this video, which I'm flashing on the screen, which explains, what is .NET Core, what is .NET Framework, and so on, right? Now, in this console application, we will try to build up our predictive feedback system. So the first thing what we need is we need the ML.NET Framework in this. So we will be using Nugget. So let us go to Nugget here. In case you are new to Nugget, I would suggest to go and watch this video, which will help you to understand what is the use of Nugget. But Nugget, what it does is it helps you to get third-party frameworks inside your project. So for example, at this moment, I want ML.NET. So you can see here, I will go and I have gone to Nugget. So let me show again. So I went to Solution Explorer, right click and manage Nugget packages. You can see there are lots of tabs at the top. So you have browse, you have installed. So the install tab says that which of the third-party frameworks at this moment is installed in your project. But we want to get ML.NET. So you can go to the browse here and search for ML.NET. So there it is. And you can see here is ML.NET. Now at this moment, I am using the version 0.8. So remember that ML.NET at this moment is at a very stage which is evolving. But I feel that it is a very great chance to learn it at the early stages, so that you can later on get ready for using machine learning with C#, right? So you can see here at this moment, this whole tutorial is targeted on the version 0.8, right? So I'm going to go and click on install here and let us install this. So I'll say, okay, yes, go ahead and get all the necessary dependencies of ML.NET. It will probably pop up you some screens of I accept and so on. Go ahead and accept everything. Okay, there it is. I accept, yes. So it is installing it's referencing the necessary components, and I think it is done with it. And if you see somewhere here, we should see right. So If you now go and see in your references, Microsoft.ml, you can see this ML out here. Now this ensures that the library is now referenced in your project and you can start with, right? So in order to install ML.NET, you need to go to Nugget and you need to search for ML.NET. Please note at this moment, we are using the 0.8 version, right? So we have the reference of ML in our C# project and we are all set to get started. Now, as we said that the algorithm will be provided training data. So let us go ahead and define the structure of our feedback systems training data. So I'm going to go and create a simple class out here. So let us go ahead and create a class, and this class will define the feedback training data. So let's go ahead and create a class feedback training data. So if you see, what we need to provide is, one is we will need the feedback text. So this feedback text is, which will have those it's nice, it's good, it's cool, it is bad, all that data will be stored inside this property. And the second thing we need is what we want to predict, right? So we also want to train our algorithm with saying that, is this feedback good or not? So you can see that I have created a class here called as feedback training data, which defines the input data structure to the algorithm. So it has feedback text and a property is good, which says that this feedback text is good or not. So let's go ahead and create a list of feedback training data. So this is going to be the training data. So we are actually creating a list, and inside this list we will be filling our training data, right? So you can see that I have created a list of feedback training data. I'm creating a generic list. So we need to import system.collection.generics, right? So now what we will do here is, let us go ahead and create a function, and that function will go and load some test data inside this training data list, right? So let us go ahead and create a function here called as load training data. And inside this, let us go and fill some training data out here. So training data.add. So let's go ahead and fill some training data. For example, we can say feedback text. So this is good, and this is a good feedback, right? Then we can also go ahead and create, this is bad or this is horrible, right? And we can say that this is not a good feedback. So what we will do is, in this load training data, let us go ahead and load some dummy data, which will say that this training text is good or not, this feedback text is good or not. And this training data, we will go ahead and give it to our algorithm. So you can see that at this moment, I have just loaded 2 values, but let us go ahead and load at least like 10-15 values. So I'm copy pasting more values here. You can see now I have added some dummy training data here. Remember that this training data can definitely be loaded from a file. We will see that example later on. But for now, for simplicity, what I've done is I have added all the training data manually, right? So at this moment, I have some 10-15 values which I have added. The only thing which you need to remember about the training data is you need to make the training data proper. For example, you can see here that whenever he finds this word good, I want him to think that this is a good feedback, right? Now, with just one occurrence, it will not work. You need to have multiple occurrences of good. For example, if you see somewhere down below, I must have again added something good out here. So somewhere down, I should have again added a data which says it is good. So for example, here it is. You can see nice and good, right? So remember that the training data should have multiple occurrences of the word, or else your algorithm will not get trained properly. So at this moment, I have created the training data and everything is out here. And what we will do is, in the static void main, before the application starts, let us go ahead and load this training data. So the first step is in our machine learning is in ML.NET is we need to load the training data. So this is step 1, right? Later on we will see how to load it from a file and so on. Now ML.NET has lots of features. It can load training data, it can do predictions, it has algorithms, it has a way to test your algorithm and so on, right? So all of these classes and these APIs, they're exposed via a central point called as the ML context. So whenever you say you want to do any kind of ML.NET operation, you need to ensure that you create an instance of ML context. So let us go ahead here and create an instance of ML context is equal to new ML context. So step 2, we need to go and create object of ML context so that we can access the features of machine learning. Now this training data can enter into ML.NET in various formats. For example, at this moment, we are providing the training data as a generic list, but someone can load an ADO.NET dataset, someone can load an entity framework collection, someone can load an array and so on, right? So what ML.NET says, rather than me getting into different formats, how about you all giving me the data in my format, which is a IDataView. So in ML.NET, we have a concept of a data view, which is very generic. So from whichever type of data source you are loading the data, you need to give finally to ML context or to ML.NET the data in the format of IDataView. So you can see that in order to use this IDataView, we need to import using Microsoft.ml.runtime.data. And also I can see that for this method as well, we need to load some couple of APIs. So Microsoft.ml.net.runtime.api, right? So you can see here, as I've said in the previous previous minute, that whatever we want, we will get it from ML context. So we are saying here, ML context, please create a data view from this training data collection. And this data view structure is in the format of feedback training data. This feedback training data is nothing but our class, right? So the next step, that is step 3, is that convert your data into IDataView. Training data comes in a very unorganized, unstructured, textual, and non-uniform formats. For machine to learn from this kind of unorganized format, it is very difficult. Machines and algorithms wants the data to be converted into specific formats so that they can learn from it. And mostly these formats are number. For example, if someone gives a text dark violet, machine cannot understand this. But if we can transform this into like RGB 148, 0, 211, where the first value stands for red and the second value stands for green and the last value stands for blue, machines can learn better and more precisely. Putting in simple words, we need to transform these inputs. Now these inputs, remember in the previous section of the video, I have said that these inputs are termed as features. So these features needs to be transformed into array of numbers, or we can officially term it as vectors. So this whole process, you can term it as featureization of the text, or you can also term it as feature vector, wherein the input features are transformed into understandable numbers, that is vectors. So now we need to do the following task. First, we have to convert the data to IDataView, and then this data needs to be transformed from unstructured data to numeric vectors. And then these numeric vectorized data will be fed to the algorithm to get trained. So we have a workflow here which involves transforming the text to vectors and then training the algorithm. This complete workflow we need to define in ML.NET in something called as a pipeline. Pipeline is nothing but it's a series of workflow which gets executed to build your final model. So let us go ahead here and create a pipeline. So you can see here, I am creating a pipeline. As we said, that pipeline is nothing but it has series of workflows. So you can see here, I am saying here again, like everything you want to access of ML.NET, either it is transformation, it is data view, it is algorithm, everything goes through the ML context. So I'm saying here, ML context, I want to do some transformation. I want to transform this feedback, which is a feature. Remember, this is the feedback text. So actually it is a feedback text, not even feedback. So this feedback text is our feature, which I want to go and convert it into vector. So you can see this is the first workflow in the pipeline process. So step 4, we need to create the pipeline and define the workflows in it, right? So here now, this is the first workflow transformation where I'm saying my feedback text, which is a feature, has to be converted into a vector. Now the next step is we need to go ahead and feed this vectorized feature or the feature vector to an algorithm. And this is the most important step in the machine learning process, to choose an algorithm. Now at this moment for lab 1, my goal is to show you how ML.NET API looks like, how to code ML.NET, what are the different processes in machine learning. I really do not want to go in this first lab itself in depth into algorithms, different types of algorithms. We will do that in the coming up labs. But at this moment, definitely we have to make a choice of an algorithm. If you see the requirement at this moment, what is the requirement? The requirement is that we have a feedback text, and that feedback text has to be categorized or has to be classified into 2 sections. Is this a good feedback or is this a bad feedback? So if somebody sends us a feedback text which says, hey, this is nice, it should go into the category of is good equal to true. If somebody says, hey, this is bad, it should go into a category which says is good is equal to false, right? So here we will use a classification algorithm, and that also binary. Binary means we have only 2 categories, true or false, male or female, yes or no. So at this moment, we do not have a lot of categories. We just have 2 categories, right? So in this pipeline, we will append one more workflow. And in this workflow, we will say, we want to go and give this featureized text to a binary classification algorithm. So you can see here now, the first process in the pipeline in the workflow was transformation. The second process is learning algorithms, trainers, right? So you can see here we are saying ML context. Again, everything we need to access through ML context. ML context, I want to use the binary classification algorithm, and I want to train the fast tree. Now this fast tree is nothing but it is a decision tree. We'll come to that later on. But this thing out here specifies the algorithm as a binary classifier. And this binary classification at the end of the day internally is a decision tree. So we also need to specify how many trees we want and how many leaves we want in that binary classification tree, right? So we are saying here we want 50 leaves and 50 trees. We'll come to these numbers later on, right? At this moment, just give the value as it is, right? So this trees are nothing but, where the decisions are done, and the leaves are the final output. And at the leaf level, I just want only one output, only one data point, true or false. So that's why this minimum data points in leaves is 1. So guys, later on, I will be explaining you what is a decision tree, what is a binary classification, what is MART, and so on, right? So at this moment, just keep this thing here itself. So we have created a pipeline. In that pipeline, we have 2 workflows which are happening. One is a transformation, and the other one is we are giving the transformed output to the algorithm for getting trained. Now, once we have defined our pipeline, the next thing is we want to go ahead and execute this pipeline and create our model. So step 5, we want to train the algorithm and we want the model out, right? So for this, we need to go ahead and say here pipeline.fit. So take this pipeline and give this data view and get the model out of it. So this line out here is doing nothing but the series of workflow what we have created, where we have decided how the featureization will take place, which kind of algorithm will come in. So into that workflow, now we are using that data view which we have created, from our generic list, and we are saying now create a model. So in the step 5, we are training the algorithm with our training data. Now this model, as I've said previously, is the heart of our machine learning output. This is the final artifact which we are interested in. Now, before we start using this model for prediction, we need to ensure that we test this model, right? So what we will do is, let us go ahead and create some test data. So I'm going to go and create one more list here called as test data, right? And using this test data, we will try to check that our model is good or not. So what we will do is, we will again go ahead and create one more function here, and this function will load some test data. So you can see here, I'm saying here load test data, right? So in this test data, what I will do is I will say that, okay, if you find this word good, that means the feedback is good, right? So let us go ahead here and create some test data. Bad, the feedback is bad, or horrible, horrible, terrible. I think these words we had already used, so this should be false. If you find the word awesome, let's look at our training data. Sweet, nice. So if you find the word nice, then this is a good feedback. So what we are doing is, we are actually going and giving some training data out here so that we can go and we can check our model, right? Shitty. So this is not good feedback, right? So this is the test data which we will run on our algorithm. So the next thing now is, step 6 is, we need to load the test data and run the test data to check our model is, how accurate our model is, or how our check our model's accuracy, right? So load test data, right? Now before we go ahead and we test our model, there are some important things we need to fix in this class. Now remember, I said that when you give training data to the algorithm, there are two important things. One is, you need to specify the feature. So you can see here, from this property we have said that this feedback text is a feature. So this code out here says that which is a feature from this class. But we also need to go and specify the output on which we will check our accuracy, or the final output which we want to predict, right? So this feedback text is actually the feature, and this is good is a label. So remember, we said there are features and labels. Features are nothing but the input which we give to the algorithm, and labels are the output, right, which we expect from the algorithm. So we need to go here and define an attribute, and we need to say here that this is a label and this is not a label, this is used as a feature. So you can see here I'm using the column attribute. So this is this label, I can just take it up. This is the first column and this one is the second column, right? So the label definition is done via this attribute, and the features is given out here in the feedback text. Again, I repeat, the specification of what are features, which of the columns are features, are defined here in the API, and what is the final output which we expect, the output which we want to predict, is defined here as an attribute, that is label. So remember, features are inputs and labels are the expected predicted output. So now this test data which we are loading in this load test data method, we need to first go ahead and create a view of it, data view of it. Remember, the previous one was training data, and this is data view one, which is test data. So you can see here we are creating a streaming data from the test data, right? And from the model, we are giving this data to the model which is now created from the pipeline. So when we said pipeline.fit. At that time the model was created, right? From this model we are giving this data to the model, and we are getting something called as predictions. So this prediction is nothing but this prediction we will evaluate. This prediction we are evaluating, saying that can we go ahead and this prediction which we have got from the model, is he predicting right or not? So we are saying that the algorithm is binary classification, and please evaluate this prediction on the base of this label. This label is nothing but the label which we have defined as an attribute ahead here. So you can see this is the label, right? So we are saying here, so over here, what we are saying is, first we are creating a data view one from the test data. We are telling the model, saying that please tell me that as per this data view, what is the prediction you can think about? So he says, okay, here is the predictions which I can think about. We are taking this prediction and we are evaluating this prediction on the base of binary classifications, right? So this will help us to check our model accuracy. So in step 5, we created the model. In step 6, we are passing him this test data and saying that as per this test data, tell me if this prediction metrics is right or not. So let me go ahead and run this program. Let us see that what kind of metrics prediction we are getting. So you can see here, or what kind of accuracy we are getting. So you can see I've created the metrics object finally. And if I go and see here, at this moment, just concentrate on the accuracy. So you can see there is something called as accuracy in the metrics. It is giving me NaN. So that means that something has gone wrong here. What has gone wrong? Isn't our test data right? Let us go and check our test data. Because normally when you get NaN, that means either the training data or the test data is not proper. Oh, there it is. You can see now this load test data, we have to load it in this test data variable, right? We have loaded in the training data. So if you remember, when I was copy pasting it, by mistake, I have taken this, right? So there it is. Now this should give a proper metrics, so what I'll do is I'll just say here console.writeLine, tell me the accuracy of this metric. So you can see I'm printing the accuracy here, and we can just say console.read, right? So let me run this. Let us see what kind of accuracy we are having. So there it is. It's saying that 60% accuracy. 60% accuracy means that if we can add more test data, if you see the coverage, if you see in our training data, we have a lot of things like average, okay, sweet. I think this all is not covered here. So if I go ahead here, average is not covered. So must be I can add average. So let me do that. Now you can see here this sweet is actually good true. For some reason I've written here false, right? And this average is also true. So my test data was not up to mark, so now let us run this. Now it should increase to 70% or 0.70 at least. Hope so. So there you can see, great, it has increased to 0.83, right? So that is so nice. So basically we are having now a model which can predict 83% properly. Okay, that's what we are having. So by all the tests we are done, our model at this moment is having an accuracy of 83%. If we go and put more test data and more training data, this will come near to 90% or 100 or must be, whatever. So that I will leave it to you. What you can do is you can go ahead and play around with the test data and training data and try to bring the metrics accuracy to more better level. So now that we have trained our metrics, the last thing we would like to do is trained our model, and also we have tested our model and it is 80% plus, right? We would like to go and use our model, right? Use the model. So to use the model, let us go ahead and first thing, let us get this feedback string. So let's get the feedback string in so console.readLine. So let's tell the end user that console.writeLine, enter a feedback string, right? So we'll tell him now that the model is ready, enter the feedback string. right? And this feedback string, we will give it to the model to get the prediction. Now, the way we have defined the input data structure for the model. So by using this class feedback training data, we have defined our input data structure for the training data. In the same way, we need now also define the output data structure, which will come outside the model. So I'm expecting from the model, so I'll say this is the feedback output, right? So in the feedback output, or I will say feedback prediction. So this is feedback training data, and this is the prediction which I'm expecting. So in the prediction, I'm just expecting him to predict the is good. So remember, so I'm going to say that I'm just expecting that you predict is good. So when I'm training my training data, I'm using two things. I'm using is good and feedback text. But in the prediction, I just want to get if this feedback is good or not. And whichever property you are predicting, you should go ahead and say that this is a predicted label. So remember, this was a label. This was, your features, right? So feedback text was the features. This was the label. Now this is the predicted label, right? So first thing is we need to define both the classes, which defines the input structure to the algorithm and the prediction structure, the output structure from the algorithm. So once we have this, now we can go ahead and start getting the feedback. Now, before I go ahead and I start using this model out here, I would like to differentiate between model and the prediction function. Model is the final artifact. Model is having all that knowledge of how you have trained him. But when you want to use that model's prediction, you have to get the prediction function. For example, when I said that I want to use this model's prediction to be evaluated, I have to say here model.transform, and then I got a prediction function which I evaluated. In the same way here also, I have to go and get the prediction function. So basically what I need to do is I need to say make a prediction function. You can see here I'm saying model make a prediction function for which the input is the feedback training data and the output is of structure feedback prediction, and the context is this. So always remember that we have model and we have a prediction function. So you cannot just say model dot predict, that we don't have. We have to actually get a prediction function. So you can see here I'm getting a prediction function where the input structure is in this class format and the output structure is in this class format, right? So now I can go ahead here and say where feedback input, right, is equal to new feedback training data. And this in this feedback input, I will go ahead and I will put this feedback text, which I'm getting from this feedback string, which I've captured at the top. Now this feedback prediction function dot prediction function dot predict. Now I want to predict what? I want to predict this one, this feedback input, right? So you can see here I'm giving the feedback input here. And what is the structure of the output of the predict? The output structure is feedback prediction, right? So where feedback predicted is this, right? So you can see now, must be you don't even have to give this, because you're already defined at the top. You can see at the top, we have already defined the structure, so I don't have to give it again. So now I can go and say here console.writeLine predicted, and we can just go and say feedback predicted dot is good, right? So that's what we want to predict, right? Console.read. Great. So first thing what we are doing is we are checking the accuracy of our model and then we are using it, right? So let us go ahead and run this and let us see what happens. I'm going to go and run this. So first thing, it will go and run the evaluation, and you can see here it says this is 83% good model by the test data what you have given. Now let us try to put a word here called as nice. Enter. Oh, what happened? I pressed enter and I just came out. Why did I come out? I think I pressed enter twice. So this is what, this is nice. Oh, it is just going out. So must be, I can say console.read line. If you just say read, it is a single character, right? So now here I will say this is nice, and you can see predicted is true. But if I go and say this is horrible, it will say the feedback is bad. Wow, see, it is working. Guys, let us do like this. Let us go ahead and put this in a while loop, so I would like to just put a while loop here. I'll say that while the feedback string, right? So what we can do is we can say that we will keep inputting the prediction until the feedback string. So while I want to just go in a while loop. So must be, I can say here, this is string str continue, right? So let's go ahead and use this continue function. So while str continue is equal to s, right? So until he presses s, we will continue with this loop, so that we can enter multiple times the things and check it, right? So there it is. So now let us go ahead and run. So I've just done a while loop, so that we can keep testing it. So if I say nice, this is good, predicted is false. If I say terrible, it is false. If I say it is horrible, it is false. Remember, we had put some input data. If I say it is okay, then predicted is true, right? If I say it is good, the predicted is true. If I say it is shitty, the predicted is true. Okay, so that is true. You can see for the shitty, it is not doing things right. Let me say shit. Oh, that is also not right. Okay, must be we need to train our algorithm more appropriately. So if we go ahead here and put some more training data around shit and shitty, must be we can get some right information. So you can see here, let's look at it. Actually, okay, so here in our training data, we never added the word shit or shitty, right? So what I'm going to do is I'm going to go ahead here and add some training data around shit. So I'll say that I'm so sorry for this. I don't know why I use this word here. Okay, I'm so sorry for this. So I'll say this is a false word and this is a false good feedback. And I'll say that this is right. This is false, right? And I will say that somebody please go ahead and test. So if you test this shit, it's good as false, right? So you can see here, it's very important that you put good training data and good test data. The more your training data is nice, the more your test data is nice, the more your model becomes better, the more your prediction functions becomes better, right? So let us see now. I've trained him with shit. See, now he's operating properly. So it's all about that, how you train your training data. This is shit. False. See, shit. It's shit. False. Awesome. Good. True. Wow. Nice. True. Man, this is horrible. False. Great. So you can see now that our model is working properly. So let us revise the overall steps involved in doing this whole thing. So you can see here, I've put down in the comments, there are like 7 steps. So let us go ahead and just go through these 7 steps once to just ensure that we understand how to use ML.NET. So the first step is we need to go ahead and load the training data. The next step is we need to create the object of the ML context. Remember I said ML context is a central point from where the API is exposed of your machine learning, that is ML.NET. And using this ML context, we first convert this training data into a data view. So that is step 3, where we convert the the training data into a data view, because training data can come in various formats like a generic list, array, ADO.NET dataset, and so on. Then this data view, we will actually go and convert it, means we will actually featureize it into a vector. So this data view is, the text is featureized into a vector, and then this vector is fed to the algorithm, and from the algorithm we get something called as model. So we call the fit method and we create a model out of it. Step 6, from this model we get a prediction function out, and we can go ahead and load test data and test that this model is accurate or not. And that accuracy we test by using the metrics.accuracy property, right? Also, we can use this model by again taking out a prediction function, and then we can go ahead and use that prediction function to even use it individually or query that model individually, right? So in all, there are 7 steps: loading of the training data, creating the object of ML context, creating your data view, after that creating a pipeline in which we do the transformation and we do the training of the algorithm. Finally, we train the algorithm by calling the fit method and we get a model out. And then from the model, we can create prediction function which can be used to test the model, or we can use the model. So that brings us to the end of this 45 minutes of training. If you are further interested in ML.NET videos, you can see www.questpond.com, where I have uploaded more such lectures on ML.NET. In case you want to take an offline training from me in Mumbai, Andheri, you can go to stepbystepschools.net, where I can be reached for one-to-one training. Now here is a small request. If you can go and put your feedback on this tiny URL, you can see that I have a small tiny URL out there. If you can put a feedback of my training, it will help me to get mouth publicity of how I teach. And in return, I will give you a data science interview question with Python ebook. So if you can put a feedback there, and if you can send me a mail at questpond@questpond.com, I will give you a Python interview question, Python data science interview question ebook. So thank you very much and happy learning.